f of x equals x minus a to b squared times b minus x, where a is less than b. Find the coordinates of the local maximum and local minimum points of the curve y equals f of x. So step 1 is to find the derivative using the product rule and the chain rule in terms of a, b and x. So we differentiate with respect to x. So let y equal f of x, which is equal to x minus a to b squared multiplied by b minus x. So the u will be x minus a to b squared, and the v will be b minus x, and we're going to sub into our product rule formula. So dy dx will be u, which is x minus a to b squared, multiplied by dv dx, the derivative of v with respect to x. Well, v is b minus x, so we can't differentiate b with respect to x because there's no x stuck onto the b, but we can differentiate minus x. So minus x, the derivative of that is minus 1. Bring down the plus, stick on v, which is b minus x with brackets, and then we differentiate u with respect to x. So u is x minus a to b squared, so to differentiate this we must use the chain rule. We bring the 2 down in front, we keep x minus a in the brackets, and we multiply by the derivative of the inside. So the derivative of x is 1, and the derivative of minus a we cannot do because we're trying to differentiate with respect to x. So we get 2 times x minus a times 1. And then we just multiply out our brackets and simplify. So x minus a to be squared multiplied by minus 1 is going to be minus x minus a times x minus a. Bring down the plus. Then we're going to bring the 2 in front, stick on the b minus x, and that's multiplied by x minus a times 1, which is just x minus a. Now the reason that we didn't multiply out these brackets is that we can spot a common term, which is x minus a, so a common factor. So we're going to factorize, so we're going to take out the x minus a, which is a common factor. So x minus a into minus x minus a times minus x minus a, well that x minus a cancels, leaving us with minus x minus a. And then x minus a into 2 times b minus x times x minus a, well that x minus a will cancel, leaving us with the 2 and the b minus x. So then we bring down the x minus a with brackets. Minus times x is minus x, minus times a, minus a is positive a, minus by minus is a plus, 2 by b is 2b, and 2 by minus x is minus 2x. And then we simplify, so again we bring down the x minus a with brackets, and we bring down the a, we bring down the 2b, and minus x minus 2x is minus 3x. Step 2, we let the derivative equal to 0. So put dy dx equal to 0, so x minus a times a plus 2b minus 3x is equal to 0. Step 3, we solve for x. There should be 2 x's and they should be in terms of a and b. So x minus a, we bring down and let it equal to 0, so x is equal to a. And then a plus 2b minus 3x, we let equal to 0. And then we solve for x, so the minus 3x comes over the equal sign, becomes positive 3x. And then we divide both sides by 3 to get the x on its own, so we get x equals a plus 2b all over 3. Step 4. Sub the x's into y, which is the original equation f of x, to find the y's, and subsequently we will find the stationary points in terms of a and b. So when x is equal to a, we swap each of those x's there highlighted in green for a's, so we get y equals a minus a to be squared times b minus a, which is equal to 0. So a minus a to be squared is just 0, so 0 to be squared, and we still have the b minus a. And anything multiplied by 0 or multiplied by 0 squared is just going to be 0, so y is equal to 0. So one stationary point is a comma 0, an x value of a and a y value of 0. So this is one of our stationary points. Now we do the same thing, but with x equal to a plus 2b over 3. So we swap each of those x's for a plus 2b over 3, and then we just simplify. So a plus 2b over 3 minus a. Well, 3 is going to be our common denominator. So 3 into 3 goes once. So we just bring down the a plus 2b. And then a is really a over 1. And 1 into 3 goes 3 times, and 3 times a is 3a. We do the same on the right. So b minus a plus 2b over 3, our common denominator is 3. b is really b over 1. So 1 into 3 goes 3 times, and 3 times b is 3b. Bring down the minus. And then 3 into 3 goes once, and 1 times a is a. And 3 into 3 goes once, and 1 times 2b is 2b, but remember there was a minus in front, so it's minus 2b. Then we simplify. So a minus 3a is minus 2a, and we still have the 2b all over 3 to be squared. Don't forget it's to be squared. And then 3b minus 2b is 1b. We still have the minus a all over 3. And then 2b minus 2a we can factorize to give 2 times b minus a. And it's still over 3 to be squared. And we still have b minus a over 3. Then 2 times b minus a all over 3 to be squared can be rewritten as 2 times b minus a over 3 times 2 times b minus a over 3. And then b minus a over 3 can be rewritten as 1 times b minus a all over 3. And we're multiplying, and we have b minus a as a factor common to each. So 2b minus a times 2b minus a is 4b minus a times 1b minus a is still going to be 4b minus a. And b minus a times b minus a times b minus a is to the power of 3. And then on the bottom, 3 by 3 by 3 is 27. So the other stationary point is a plus 2b over 3. That's our x value. And 4 times b minus a to the power of 3 over 27. That's our y value. And note that both our x and y values are in terms of a and b. Step 5. Find the second derivative using the product rule in terms of a, b and x. Remember to differentiate with respect to x. So dy dx we worked out to be x minus a times a plus 2b minus 3x. So we're multiplying these, which means we're going to use the product rule. So the u is x minus a, and the v is a plus 2b minus 3x. Then d squared y dx squared is our second derivative, is going to be u, which is x minus a, multiplied by dv dx, the derivative of v with respect to x. So this term a has no x value, so we can't differentiate. This term 2b has no x value either. So minus 3x is the only term that has an x value, so the derivative of minus 3x is minus 3. We bring down the plus, we bring down the v, which is a plus 2b minus 3x, and then we differentiate u with respect to x. The derivative of x is 1, and we can't differentiate minus a with respect to x. Then we multiply. So x times minus 3 is minus 3x, minus a times minus 3 is positive 3a, and then a times 1 is a, 2b times 1 is 2b, minus 3x times 1 is minus 3x. Then 3a plus 1a is 4a. We bring down the 2b, and minus 3x is minus 6x. So this is our second derivative in terms of a, b and x. Step 6. Sub x into the second derivative. If we get a negative result, we have a maximum, a positive result, a minimum. Remember, the question says a is less than b. It says it up here. So our second derivative is 4a plus 2b minus 6x. So our first x value was a, our second x value was a plus 2b over 3. So subbing x equals a into the second derivative. So we have 4a plus 2b minus 6a, so swapping that x for a. So we get 2b minus 2a, and that factorizes to give 2 times b minus a. Now 2 times b minus a is going to be positive, it's going to be greater than 0 if a is less than b. So let's say, for example, if a was to be less than b, let's say that, so we know that A must be less than B. So let's say that B was 4, and let's say that A was 1. So A is less than B. So 2 times 4 minus 1 is going to be 2 times 3, which is 6, which is positive. So no matter what values you could sub in for B and A, so long as A is less than B, you're going to get a positive answer. So since when we sub our x value, which is A, into the second derivative, and we get a positive answer, the point A comma 0 must be a local minimum. Now we're going to do the same with x equal to A plus 2B over 3. So we swap that x for a set of brackets and put A plus 2B over 3 in it. Next, we bring down the 4A and the plus 2B, and then we multiply in the minus 6. So minus 6 times A is minus 6A, divided by 3 is minus 2A. Minus 6 times 2B is minus 12B, divided by 3 is minus 4B. And then we simplify and we factorize. 4A minus 2A is 2A, and 2B minus 4B is minus 2B. Factorizing gives 2 times A minus B, which is going to be less than 0, no matter what A and B value you have, because again, remember, A is less than B. So let's have a closer look at this. So if A must be less than B, and let's say, for example, A, which we know is less than B, let's say that A was 2, and let's say that B was 4, so A is less than B. This would give us 2 times 2 minus 4, which is minus 2, which is minus 4, which is always going to be negative. So no matter what our A or B values are, so long as A is less than B, our result will always be negative. And thus, the point A plus 2B over 3, comma 4 times B minus 3 to be cubed over 27 is a local maximum. So A comma 0 is a minimum, and A plus 2B over 3, comma 4 bracket B minus A to be cubed over 27 is a maximum.